Welcome to iTTV for Form 4 Physics. The title of this lesson, Pressure. We're entering a new chapter, which is the chapter on force and pressure. This word pressure is a common word that we hear on a daily basis. I'm sure you've said at home to yourself, I have so much pressure. Pressure from your parents or pressure from school, examination pressure. This word pressure, we use it when something is pushing on us, that's making us feel uncomfortable. This word comes from the physics word pressure, where pressure is basically when a force acts on an area. Example is, if I take this little block. This block has a weight, which will be the force. If I put this block on my hand, the weight of the block is acting downwards on a small area of my hand. We have a force acting on a small area, and I can actually feel the block on my hand. What I feel is the pressure. So mainly pressure is caused by the weight of an object pressing down onto a surface. Pressure. Pressure equals force over area. We define the term pressure to be this: force per unit area. So remember the formula for pressure. It is force over area. And remember what I said earlier, the force is generally the weight of the object pressing down. The units for pressure is Pascal, PA. It comes from Newton meter squared. Pascal is a special terminology given to pressure, named after Blaise Pascal, who caused a lot of changes in our thinking on pressure in the 15th and 16th century. We'll talk a little bit more about Pascal in a later lesson. Pressure can be changed by changing the amount of force acting on an area. Pressure can be changed by changing the area on which a force acts. So we can change pressure by playing with the amount of force or playing with the area. Now, in terms of questions that you're going to deal with in examinations, the main relationship that we deal with is the relationship between the pressure and the area. We're going to focus a bit on that in this lesson, but not to forget that if you increase the force, the pressure will also change. We'll do one or two questions on force and pressure later on. If you are using a dull knife, then the area of the knife blade which presses against the bread is large. The pressure is small. The result, harder to cut. So what we are saying here is that if you use a large surface area, you create a low pressure. This is really important. We can apply this in many different ways. The larger the area, the lower the pressure produced. Large surface area, low pressure. Small surface area, high pressure. And there are many examples of this. One of the most famous examples are when people sleep on a bed of nails. Now we always imagine that a nail, being so sharp, will poke straight into your back. But the trick to it is they don't use one nail, but they use many nails. If you take all the surface areas of all the nails and add them up, what you get is a large area, not a small area. And remember, a large area is going to produce a low pressure. So the low pressure is not really going to hurt the man or the woman who is sleeping on the bed of nails. Just a simple trick using physics. Relationship between area and pressure is inversely proportional. Example, rhinoceros has large soles, so low pressure. Why? Does not sink into the ground easily. So we need to be able to explain the relationship between area and pressure using physics terminology. Remember, we use this phrase proportional and inversely proportional. In this case, what happens is when the area becomes larger, the pressure becomes smaller. They are opposite to each other. So we say inversely proportional. The area is inversely proportional to the pressure, which means when the area increases, the pressure will decrease. If the area becomes twice as big, the pressure should become twice as small. So remember this key terminology, inversely proportional. So area is inversely proportional to pressure. So remember the key things that we've had a look at. Pressure, it is produced when you have applied force on a particular surface area. We get the formula, pressure equals force over area. And remember the key things that we said. The smaller the area, the higher the pressure. Bigger area, lower pressure. Now let's go up to the board and have a look at what we've been discussing and have a look at one or two examples and maybe one or two simple calculations. So remember, what we are looking at is pressure. Let's start with the formula for pressure. We said that the formula is force over area. So pressure equals force over area. What we have is an object, let's say like this. This object has got a weight. That weight equals F. The bottom of this object, down here, this area that I'm marking in a darker color, that represents the area that the weight is acting on. So this is A. This is your area. So if you take this force over this area, you find, very good, the pressure. Now, what were the key relationships? If we look at the formula here, pressure equals force over area, which means that pressure and force are directly proportional. If your force increases, your pressure will increase. What about the relationship between these two, pressure and area? What we get here is, if the area increases, the pressure decreases. So remember, this is directly proportional. The bigger the force, the bigger the pressure. Secondly, the area, the larger the area, the smaller the pressure. Now let's have a look at one of the coolest things that was ever invented, the thumbtack. Now a thumbtack is shaped like this. Now if you look at the design of a thumbtack, it explains the relationship between area and pressure very, very simply for us. First, we look at the top of the thumbtack. Here we have a large area. So the area is large, which means that the pressure must be low. Why do we need a large area with low pressure at the top when we are pressing down? Well, the chances are we get less pain. It doesn't hurt us when we press the thumbtack in. Now let's look at the other end of the thumbtack. Let's look at this end. Here, what we have is an area that is low or small, which means that I'm going to produce a large pressure. Why do I need a large pressure here? Well, the reason is the thumbtack will enter the surface easily. The easier it enters the surface, the more useful the thumbtack is. So this is an example of how we apply the idea of large area, low pressure, and how we apply the idea of small area, high pressure. We've got many applications that we use in our daily life where we are using the idea of big area, small pressure, or vice versa. Question. Explain the following. High heels. The area is dash, so the pressure is dash. So we're looking at a high heel shoe. In high heel shoes, the key here is the heel at the back. Now let's just go up to the board and sketch a simple high heel shoe over here. What we have is a pair of shoes like this that goes up, and it's got this heel at the back. What we want to understand about the heel is what is it going to do in terms of pressure? What is the relationship to the area? So sketch out a heel for yourself. Pull out an arrow like this. Ask yourself, has it got a large area or a small area? Small area. So if the area goes down, what's going to happen to the pressure? The pressure is going to go up. Very good. You have your answer. So remember, once again, with physics, it's very useful to sketch a diagram and put in all the information that you know and then work out what the answer is going to be. So let's have a look at the answer. Answer, area small, pressure high. Let's look at the second example, tractor in mud. Now, we want to do the same thing with a tractor in the mud. So, once again, sketch out your tractor. What we really want to look at are the wheels of the tractor. So, if you have a tractor, down here it's got really wide wheels, like this. Now, what is the key to the wheel? So here, put down the word wheel for yourself. What about the area? High or low? So here you've got an area that is large. How is that going to affect your pressure? Your pressure comes down. So what do you get here? You get a relationship where the area is increasing, therefore your pressure is decreasing. Let's check the answer. The area is large, so the pressure is low. Remember, once again, always sketch these diagrams out so that you can work out what's happening in the physics question before you. Let's try another question. On a table is a full box of groceries which has a weight of 160 newtons. The area of the base of the box is 0.2 meter squared. What is the pressure between the box and the tabletop? Well, I don't know what you're waiting for. You need to start sketching straight away. A simple sketch is all we need. Let's use this area over here. We've got a table with a box of groceries on it. We know the weight has been given to us as 160 newtons. So F equals 160. The area has been given to us as 0.2. Find the pressure. Pressure is force over area. Quickly do the maths. Let's check the answer. The answer, 160 divided by 0.2 equals 800 Pascal. Question, what is the function of X? A, to increase weight and to increase pressure. B, to increase surface area and to decrease pressure. C, to decrease weight and to decrease pressure. D, to decrease surface area and to increase weight. So you've got a bag strap here. Now, once again, this is something that you can sketch very easily. So what you should be doing is something like this. You've got your bag strap. So draw a bag strap. Now, on the bag strap, you're putting an extra layer of sponge on it. Just draw the extra layer of sponge there. Now, ask yourself, what is the key relationship here? Obviously, the area is increasing. Therefore, your pressure must be decreasing. You see, the sketch will allow you to see what is happening and then you'll be able to work out your answer. Let's check the answer. B, to increase surface area and to decrease pressure. Question. Compare the surface area, depth of sinking and the pressure in the diagram above. Relate pressure and surface area. This is a typical open response examination question. There are 3 steps to this question. We've done these questions before, so please remember what you must do. Explain each comparison first, then do the relationship. So first compare the area in diagram A and diagram B. Write it out. Remember what I said, there's no point thinking about it, you must write it out. Thinking about it is bluffing yourself that you're doing work. Have you written out the comparison? Good. Now write out the comparison about the sinking in both the diagrams. Remember, just use simple words. Sink more, sink less. Done? Let's do the next part and talk about the pressure in the diagram A and diagram B. Once again, simple words. Higher pressure, lower pressure. Good. Now do the last part. Relate the pressure to the area. Like I said before, select one diagram and talk about the pressure and the area in that diagram. Keep it simple as well. Small area, high pressure, or vice versa. Done? Let's check the answer. The answer. Area. Area in diagram B is larger than A. Sinking depth. Greater in diagram A compared to B. Pressure in diagram A greater than diagram B. Smaller the area, higher the pressure. Applications. Studs on a football boot have only a small area of contact with the ground. The pressure under the studs is high enough for them to sink into the ground, which gives extra grip. So this is a typical example of using the idea of area and pressure. The football boot studs are a small area, so they will create a high pressure and they will sink into the ground a little bit more, which gives the football player some extra grip. It's a similar thing with spike shoes or even ice skates. Application. Thumbtack. Wide head, so low pressure. Does not injure finger. Small point, so more pressure. Push easier into wood. So this is the thumbtack which we discussed earlier, and how the thumbtack has got both the big area and small area at the 2 different sides because of the 2 different needs we have with a thumbtack. Tractor. Wide tires to reduce the pressure on the ground so that they will not sink. Now you'll notice that when we talk about the applications, it's very important to always, at the end of your explanation, large area, small pressure, explain the effect. Does not sink into the ground. Can cut the food easier. Gives extra grip. Don't forget, in the end, when we apply physics, we need to explain how it helps us. There's no point you just explaining the relationship and don't explain how it affects us ultimately. So remember, small area, high pressure, more grip. Something like that will get you full marks in an examination. Lab. Relationship between area and pressure. To investigate the relationship between pressure and surface area, our materials and apparatus are a 1/2 meter ruler, a weighing scale, plasticine, and 4 weights of different surface area. The weight with the smallest area is placed on the plasticine, which is then placed in the middle of the weighing scale. We press down on the weight until the reading on the weighing scale reads 30 kilograms. We hold it here for a few moments. We then release and measure the depth that is being produced. The depth of the dent will give us an idea of the pressure being produced. We repeat using the other weights. So we start now with the second weight. We press down, once again making sure that the force applied is 30. We remove the weight and measure the depth. We repeat with the third weight, once again making sure that the force applied is constant. The weight is removed and the depth of the dent is measured. Now we do it for the final weight. Remembering to measure the depth of this dent. What we notice is, as the surface area increases, the depth of the dent decreases. The largest area has the smallest depth of dent, and the smallest area has the deepest depth of dent. Area and pressure are inversely proportional to each other. Finally, a quick summary. Pressure is force over area. Remember, the force is the weight of the object. The area is the area that is in contact between the object and the surface. The key relationship: large area, low pressure. Small area, high pressure. That is an inversely proportional relationship. Remember the relationship between force and pressure. Higher the force, higher the pressure. Remember the applications that we had. The football shoe studs, or like I said, spike shoes of an athlete, or the ice skate. Sharp knives or dull knives. The thumbtack. The carrier bag strap. All of these applications. Remember to draw the diagram. Work out what the relationship is between area and pressure. After you've drawn the diagram and worked out the relationship, explain it clearly, and don't forget, what is the ultimate effect? More grip, cuts easier, moves into the wood, less pain on your shoulder. All of these are explanations on how we use the idea or concept of pressure in our daily life. That's all the time we have for this lesson on pressure. Thank you for watching iTTV.